Hello, and welcome back to yet another retro channel. Today, we're going to be looking at machine number 4 in our epic Commodore 64 Repairathon. But before we do that, I just wanted to remind you, and for those of you watching this in the future, I apologize, but for those of you watching it on the day of release, which will be Saturday the 15th of April, just wanted to remind you that on the 16th of April, tomorrow, 2023, I, along with 4 of my friends, YouTube Retro Repairs, Steve from 8-Bit Retro Refix, Lee, better known as Captain Commodore, and Neil from Retro for You, and Joseph from Joseph's Retro Bits. We'll be holding a live, and you can see the information for that on the screen now. That will be, again, tomorrow, Sunday, April 16th, 2023. It will be at 2:30 p.m. Eastern Daylight Time, which is 11:30 a.m. Pacific Daylight Time, and 7:30 p.m. Greenwich Mean Time for those of you in Great Britain. If you don't already realize this, if you haven't watched their channels, the other 4 fellas in my group are based in Great Britain. Joseph's not originally from Great Britain, but he lives there now, and the other 3 are native-born Brits. So please join and watch. We'll be discussing, I guess, our histories, how we got into this, why we do it, why we love the world of retro computing, telling stories, probably poking fun at each other quite a bit. And it'll give you an opportunity to get to know us. You can also ask us questions, and we'll do our best to answer them. So if you're free tomorrow afternoon, tomorrow evening, go ahead and join our live and get to know us a little better. That being said, it's time to talk about machine number 4. Let's go. Okay, machine number 4. In this case, we only had 2 socketed chips, the SID and the VIC-2. In our initial testing and review, apparently I was able to get as far as dead test. So I'm showing bad U10, which is this memory chip right here, and bad U1 and U2, which are the 2 CIAs. That's not good. CIAs are hard to come by. I've got some on order, but I think I only have 2 spares remaining. So I may be able to fix this board. May not until the spares come in. But if you can't, you probably can't see from that distance. But apologies for the shaky cam. But here's what I wanted to show you. What you're looking at there is the RAM on this machine, and if you'll notice, every single one of those chips is an MT RAM. So instead of just replacing the one U10 that's showing bad in the dead test, I will probably end up desocketing and resocketing all of those ICs. As we know, MT RAM is notoriously unreliable, and I want to make this thing as future-proof as possible. So we will take care of that. Okay, the next thing we're going to do is we are going to check our voltage rails again. Should let you know, or I should mention this. I have skipped some steps here in the interest of time, so I've already resoldered the power switch, and I've already cleaned the power, video, AV, and IEC sockets with deoxit. So that's already been done. So let's go ahead and hook up our power and bring the machine online. I apologize for the glare on the multimeter. Okay. So we'll now take a look at our 5-volt regulator. 4.99, perfect. Our 12-volt regulator, 12.12, also perfect. Then we will look at the voltage on the CPU. That's pin 6. 4.87, that's perfect. DC voltage on the user port, 4.86, that's perfect. And then finally, our AC voltage on the user port, 10.34, that's perfect. So we know our voltages are good. The next thing to do will be to check the two socketed chips, the VIC2 and the SID. And this is an R4AR SID, so I'm really hoping this is good, solid, steady working because it's a nice chip. But we're going to check those using the zip board. Okay, I'm sorry about that. I've been having a little difficulty with my HDMI capture card, so to show the output of the computer, I'm going to have to use the old-fashioned approach and aim a camera at the monitor. So here we go. Okay, so the ZIF machine is working properly. So now we can test our two chips that were socketed. We will start with the VIC2. We'll hope we don't have another bad VIC2. I don't think we do because of the testing we were able to do in the first video. So let's pop the VIC2 into the ZIF socket, make sure everything's in all right. Lock it down, and here we go. Yep, our VIC2 is working just fine. So that's an easy one. Put our original VIC2 back, and we're going to check the SID. Nope. So that's a disappointment. That SID is only partially working. Boy. I was hoping to have a good R4AR, but it looks like no, it's a marginal chip. So we'll set that off to the side. And we won't be using that again. Okay, so back to our board under test. Now, these two sockets are both crap sockets, but we'll see if they will work. So we're going to replace the VIC2. And we're not going to put a SID in at all at this point. And I forgot something. I forgot to deoxit the VIC2 socket. Got to do that. All right, Vic2 back in. Okay, and let's see where we are. Start with dead test. We know our voltages are good. Let's see where we are with dead test. We have 4 flashes on dead test. So, okay, so 4 flashes is U23, which is this guy right here. Now, before we had indications that U10 was bad, as this guy right here. In any case, all of these, as I said, are MT RAM. So I'm going to just go ahead and take the precaution of pulling them all and replacing them with good chips. So first thing I need to do is pull these chips out. Okay, well, that was an interesting exercise. First, my little memory tester, cheap memory tester, seems to have crapped out on me. It wouldn't read any of the chips, so I had to skip that and go directly to testing in the ZIF machine. First thing I did was I went back and tested the MT RAM chips, and it turns out 2 of those were actually bad. The other 6 are good, but they're of course MT RAMs. So then I went into my stores and started testing replacement 4164s, and before I found the 8 good ones that I needed, I found 10 that were bad. So my stores are reduced by 18 because of 10 bad and the 8 that I'm putting in this board. So that being said, there are now 8 good working non-MT RAM chips in this board, and we're hooked back up and we've got the dead test in, so we're going to see what we get on the dead test now. And I'm betting we still get flashes because I'm betting the PLA is bad. Yeah. 5 this time. Let's see what we get. See if we get different ones. 4 this time. Yeah. 5 one time, 4 the next. That is a PLA fault. So we are going to pull the PLA. Yay! As usual, we will add a little solder to the pins of the PLA to make it easier to desolder them. While the desoldering station is heating up. And don't see any bridges. So this is ready for a new PLA to go in, if that's indeed the issue. Get the ZIF board. And see what we get. No. That PLA is good. Huh. That's interesting. Okay. In that case, it is time to start probing signals and looking for what might be clobbering either the address or the data bus. Interesting. I'm just going to check real quick that I didn't bend a pin when I installed this memory. U23 is 5 flashes, and we were seeing 5 flashes. Nope, no bent pins there. And 4 flashes is this guy. We also saw 4 flashes. So no bent pins there. Okay. First thing I'm going to do, since I did put those sockets in, and I haven't done this yet, is I'm going to check for continuity, as most of these pins are common among the RAM. The continuity is right on the chips. All right, actually, let's go through the basics so you can see what I'm getting. So we will take another look real quick at reset. Again, it should stay low for a split second and then go high when I turn it on. Oh, that's the clock. There is reset. Yep, that's right. Clock in 1.02 megahertz. Clock out 1.02 megahertz. Let's look at ready. Staying high, I don't like that very much. What? Okay, this is IRQ and it is stuck low. That's not good. Does it do anything? It's high for a moment and then it goes low. Okay. That's a new one for me. Yeah. Oh, I'm going to need some schematics. Okay. After consulting the schematics, the IRQ pin, pin 3 on the CPU, it seems to go 3 places. The first place it goes is to the VIC2, pin 8. Now, we have already tested the VIC2 in the ZIF machine. It worked fine. It did not pull the IRQ line low and hold it there, so that is not the problem. The second place it goes is to the cartridge port, pin 4. It goes there past this, or by this resistor pack. This is a 3.3 kilo ohm resistor pack, and it's a pull-up. It's pull-up resistors is what it is. So there's 5 volts on pin 1, and there's 3.3 ohms, 3.3 k ohms between each of the other pins and pin 1, or at least that's the spec. Now there is a slight problem here. When I test between pin 1 and pin 3, which is the pin that connects to the IRQ line, that particular pin only has about 2.57, I think it was, kilo ohms. That shouldn't be an issue. However, it might be. So that's something to consider. But the third place that the IRQ line goes is right over here to U1, which is the CIA. Now, if you remember back to the initial testing video that we did on all of these, machine number 4 had a bad U10, it claimed, which is one of the memories, so we may have dealt with that. But it also showed U1 and U2 bad. So there's a good likelihood that U1 is the problem with the IRQ. What I'm going to do to test that real quick is I am actually going to snip that pin. I know some people don't like doing that, but in this case I think it's an appropriate check. So what I'm going to do is I'm going to snip pin 21, which is IRQ. Make sure it's not making a connection. And I am going to start the machine up again. And I'm going to check IRQ, or actually, let me get connected over here. I am going to watch IRQ on the CPU with pin 1 snipped. So remember, it should stay high. And it does. So our problem with the IRQ is CIA number 1, U1 right here. So we're going to have to pull him and replace him. Get one of our remaining spare CIAs. Okay. Now let's see if we get anything different. Still black screen. So take a look though at IRQ and see what that's looking like. Our IRQ is still going low and staying there. That's not good. And 21 on the CIA. Does the same thing. Well, that's interesting. Okay. Sadder thing is that might mean that this CIA that we pulled out is actually good. I'm going to test that theory by putting a leg back on it and putting it in the ZIF machine. I wasn't even going to test it if that replacement solved the problem. Okay, so I went ahead and soldered the pin that I snipped back on the CIA from the broken board and put it in the zip machine, and here's what we get. And U1 is good, and everything is good. So that CIA is not bad. Now, if you remember, when we initially tested these boards, number 4 actually booted. It just didn't have the right amount of memory, and when we ran the diagnostic on it, it said U10 was bad, along with U1 and U2. So far today, we have not been able to boot this machine or run the diagnostics. So somehow it got worse between the initial inspection and today's repairs. I don't know what's going on yet. I think I'm going to go ahead and start probing some signals again. I kind of got distracted the last time I started that when I found the IRQ low. So I don't know what's going on there. When I turn this machine on and probe the IRQ line, without that CIA in, it stays high. If I put the CIA in, it goes low and it stays there. So something is affecting that CIA. So what I'm going to do is I'm going to continue to probe. Again, when I've got this machine running and I probe IRQ without that CIA in, it stays high. If I put the CIA in, it goes low. So let's continue to probe, see what else we got. Non-maskable interrupt is high, which it should be. AEC pulsing, which it should be because that is what That's a signal that allows the VIC2 to have control. VCC 5 volts where it should be. And we start getting into address lines. This is address 0. It looks good. 1 looks good. 2 looks good. 3 looks good. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm not sure I like those little peaks on 14. That may be an issue. We can come back to that. And 15. Got the same issues. So then we look at the data bits, and those start at 37 going down. 0. Those little half peaks in there, I don't like those at all. 1. Looks like there's a problem there too. 2. Yep. 3. Yep. 4. 5. 6. And 7. So it looks like there may be a problem on the data bus. I want to check pin 20 on the basic and character ROM. Basic. I don't know, that may be okay. Or basic and kernel ROM rather. Kernel. That looks okay. And then character. Not sure about that. I'm thinking there may be a problem with one of the ROMs. So, I think I'm going to go ahead and pull the ROMs, put in sockets. At the same time, I'm going to pull the other CIA and socket it. That way we can take out every chip, the 2 CIAs, the 3 ROMs, the SID's already out. We can pull all the chips that are not needed for dead test and try that way. So let me go ahead and do that. And you get to, well, I'm not going to make you watch a big montage about these. So I'm going to go off camera to do this. Okay, so I have pulled now both CIAs and all 3 ROMs and put in sockets. And we're going to try this with the dead test without any of those chips. Dead test should not require them. So I should be able, if all else is equal, I should be able to start up dead test. Let's see what happens. And we get nothing. Okay. Well, that takes it down to this logic. So let's see what we've got here. All right, these two chips look like they're both 4066s, but okay, so that 4066 was bad. I tested it in the Mini Pro, and it tested bad, so I replaced it. Well, actually, one thing I didn't do is test the replacement. Let's test the replacement. Okay, so we have 4066 selected, and this is the replacement, and it tests good. Okay, so I put in a good 4066, put in the good 4066, and we still get flashes. And I know that that memory is good. So that wasn't the issue. We do have one MOS branded logic chip. So that is the MOS 7707, and it's, I believe, yeah, it's a 74 LS06. So I'm going to pull that and replace it. Okay. And now my last remaining 7406, I'm going to need to reorder those. Make sure first that it's working. Oh no, it's no good. Ugh, oh wait. Yeah, there we go. It's good. I had the wrong test. Which probably means I had the wrong test on the other one, on the old one, so I should retest it just to be on the safe side. But we'll go ahead and install this. There. And retest the MOS one. It'll pass. Watch. And it passes. So it's good. Okay, guys. I'm going to have to call it a night. I'm exhausted, but the last thing I will do before I go to bed is I'm going to bring the ZIF board up, and we're going to test these chips that I pulled, so I know which ones I can put back and which ones I can't. Now, this is the CIA that I pulled first, the one that I snipped the pin on. It tested good a little while ago, so I don't have to test it again. Let's test the second CIA out of the broken machine. See what I get on it. First thing we'll want to look for is that the times change, and they do, in sync, so at least that part of the CIA is working. All right. That CIA works. Okay, let's check the kernel ROM. That's the easiest. All right, this is kernel. Does this kernel work? Yep, that kernel works. Oh, yeah. Since I don't know what the checksum should be, to check basic and character, I'm going to take the diagnostic cartridge out. Okay, basic is good. And the character ROM is fine. So all the ROMs are good. Both the CIAs are good. Well, I'm sorry, but I'm afraid that's going to have to do it for this week. I did not want to do another two-parter. I wanted to get that done in one shot, but it's kind of kicking my butt. So join me next week when we will dig deeper into the remaining logic ICs. We will probably be getting out the logic analyzer to take a look at those chips so that I don't have to indiscriminately pull them and replace them, not knowing whether they're bad or not. I want to actually discover what is going on with them and which one or ones are bad. The logic analyzer will help me do that. There is also one remaining major IC that we haven't touched, and that's the CPU. It seems to be working. It's getting its clock, it's getting its reset signal, and it is working at least as far as being able to run the dead test to the point of testing memory and giving us flash codes. So I don't think the CPU is the issue, but it could be. So we may have to take a look at that as well. So join me next week when we finish this all up. In the meantime, please don't forget tomorrow, Sunday, April 16th, 2023, the 8-bit YouTube Retro Repairers live stream. That will be 2:30 Eastern Daylight Time, 11:30 a.m. Pacific Daylight Time, or 7:30 p.m. Greenwich Mean Time. And that's hosted over on 8-bit Retro Refix's channel, so you can go there to find the live. You can also use the link in the description below. So we hope to see you there. We think it'll be a good time, and I guess that's all I have. I'm sorry, like I said, I did not want to do another two-parter. I wanted to get this done in one for you, but it just didn't work out that way. So until either tomorrow or next week, be safe, be well, And we'll see you then.